So next thing we're going to do is a little example of a graph editor. So this is going to be one where you're going to drop some shapes on the screen and then move them around, connect them using some lines, and then as you move them, the lines will move and so on. So it's like, a network graph type thing. So to start with, let's create let's go inside here. I'm going to create a new file. I'm going to call it graph. And he's going to be composable. And we'll say fun graph. And let's pass in the modifier to start with for him. Oops, now I just screwed up there. You see how I imported JavaLang reflect modifier? Definitely the wrong modifier. So I want to make sure I do the compose one there. Okay, and then inside here, we'll do our canvas with modifier equals modifier. And then there. So far, so good. So what we're going to do is draw some shapes. So we're going to need a few more parameters in this. What we're going to have is, let's say, a shape size. And the shape size is going to be a square shape that I'm going to be defining. So a square that's going to contain the shape. So shape size dp is going to be a dp. And that's going to default to 48.dp. 48 is a really good number for if you're looking for a thumb size or a typical thumb size. Now I know everybody's thumbs are different, but kind of like an average-ish thumb size, 48 dp works really well. Okay, and let's do a shape outline width. So each of these shapes is going to have a little outline around it. And shape outline color. It's going to be a color, and we'll default that to black. And then we're going to start by drawing a triangle. So let's have a triangle color. We'll say color.red. So that'll be the first thing that we draw inside of here. Now that we've got this, we have to convert our DPs into PXs. We're going to be using these a lot, so I'm going to define a variable up near the top of this for it. Not going to remember it because it's a quick calculation. So I'm going to say with local density.current and oops, got to do this outside of the canvas and put the canvas inside of it. Okay, so because local density can only be accessed inside a composable function, just like when I was calling the 2px before. So let's do a val shape size px equals shape size dp 2px. And then what's the other one there? Shape outline width px equals shape outline. Wait a minute. Oh, uppercase. Shape outline with dp.2px. There we go. So there's a couple little guys we can do that. And what we're going to do is define a path to draw our triangle. We could explicitly do drawing commands, but paths are really nice because you can use them to define a common thing you're going to stamp on the screen over and over again, rather than having all these individual lines. You can also use paths to do things like calculate the center of the shape that you're creating. So I'm going to create a val triangle path is going to be a path. Did I import the right path? I did not. That is definitely not the right path. Let's import Android Compose UE Graphics. That's the one we want. The other one was a file path for Kotlin. So some of these words get overloaded quite a bit, and so sometimes getting the right one on the import can be a little dicey. So be really careful when you see multiple imports pop up. Now what I want to do is I'm defining this path, and I want to add things to it. So I would say things like triangle path dot move to, and then let's say shape size px over 2 comma 0f. So this is going to be a corner at the top, or one of the corners of the triangle at the top of the square, right in the center. And then I can do a line to shape size px, shape size px. So this is going to be a bottom right corner. And then I can do a line to 0, shape size px. That's going to be the lower left corner. And then I can say triangle path dot close, which just closes it off. That sends a line back to the first point it started with. Now there's a nicer way to do this. I can take advantage of the scoping function apply in Kotlin to pull all these in a little bit less verbosely. So I can say dot apply, and inside there, move these guys up. Whoops, actually, let me just copy those so I can comment them out. And then I can just say bloop, bloop, whoops, too much. Just like that, which I think is a little bit cleaner to read. And what apply does is it takes its receiver, passes it in to this lambda as this. So this is the same as me saying this dot move to, this dot line to, this dot line to, and this dot close. So a little bit cleaner. And then at the end of all that, it returns whatever this was. So apply is great for initializing objects. You create the object, then initialize it. Cleaner than this. Let's comment him out. But works the same as. So, think about apply whenever you're thinking about initializing an object that you've created. So now I'm going to define a little function in here that's going to let me draw the triangle. Now, one thing I'm going to do in this example that I'm showing you is I'm putting a lot of nested functions inside of here. That reduces a lot of parameter passing. There's a couple that I'm going to still pull out because they really discourage creating nested composable functions. So those I'm going to pull out. But defining some helper functions inside here can reduce the amount of parameter passing that you have to do. So I'm going to define a fun drawScope.draw triangle function. So I'm defining an extension function on top of drawScope, which is the one that has all those draw path and draw line and draw circle type functions. And what this guy is going to do is take in an offset for where I want to draw that triangle. And I'm going to consider that offset to be the upper left corner. And then down here, I'm going to move my page over to that offset. So I'm going to say translate, passing in offset.x and offset.y. And so what this does is this makes 0, 0 be positioned at offset x and offset y. So inside here, I can just draw as though I'm drawing at 0, 0, which this triangle path really likes. Otherwise, what I'd have to do is add the offset x and offset y to all of these points inside of here. It's just much cleaner to be zero-based when you're defining this, and then let the translate do that adding for you. So then inside here, I'm going to say draw path, and we'll say path is triangle path, and then we will do a color is going to be triangle color, and then style is fill. So once again, we're going to draw the background first, and then this is going to be outline, shape outline color. And we're going to need a stroke. Now, because I could be doing this multiple times, I want to define that stroke once using a remember. So I'm going to say val shape outline stroke. equals, remember, and then he's going to be based on the shape outline width. And I'm going to need to move this outside because remember is a composable function, but I'm just going to keep defining it just for the moment, and then we'll move it out. And then we'll say, oh, come on, stroke oak. And we'll pass in the shape outline with px. There we go. Oh, I'm actually inside there. It just wasn't happy because I hadn't filled in I hadn't edited returning anything. I thought I was actually inside my canvas, but I'm not. Okay, so there's my shape outline strokes, and now I can use that inside of here. Shape outline stroke. Now, depending on how many types of helper functions you define, you may want to go ahead and pull them out and make them separate. Just keep in mind you're going to have to pass everything as a parameter. Triangle path, triangle color, shape outline color, shape outline stroke. Those would all have to be extra parameters to this draw triangle function. Okay, but as a nested function, he has access to everything that is defined around him. Okay, so now what we can do is we're going to try to figure out where we want to draw on the screen. This translate moves the upper left, or moves 0, 0 to the upper left location and then draws from there. But what actually might be really nice is to be able to draw based on the center of the shape. So when I click somewhere on the screen with my finger, I'm going to be drawing the shape right underneath the center of my finger, and that'll actually feel a little bit more clean. So what I'm going to do is let's do a val half, ooh, come in, half shape. Oh boy, this one doesn't, my fingers do not like this one. Offset equals offset, passing in shape size px over 2 and shape size px over 2. So we can use that to back off from where we're going to be drawing. So when we draw something, we'll just kind of move back a little bit. So for here, I'm just going to do a val offset equals center minus half shape offset. And then I can do a draw triangle at that offset. If I didn't do this, if I just passed in center, then the triangle would have its upper left corner, well, the upper left corner of the square containing the triangle, at the center. So it'd be a little bit offset. It might look a little odd. Let's actually see what that looks like. And we might not notice it too visibly here, but let's see what that looks like. And I didn't call graph yet, did I? No. And we'll say modifier equals modifier dot, did I use the right modifier? Yes, okay. Modifier dot padding like that. And let's see how that looks. Oh, and once again, one of these days I'm going to remember to fix that up. Okay, so we'll change this to 18, change this to 10. At least you have several examples of what you need to tweak. And we'll sync it. And whoops, that doesn't look right. That looked very wrong, by the way. So draw triangle, passing in, oh, I was passing in center. And, oh, I didn't do, yeah, I didn't do my fill max size. That's the problem. That's at least one of the problems. I'm not sure about the color. Because I didn't say fill max size, it ended up giving 0, 0 space for the component, and then it's actually overdrawing. It's still black, but it's that now it's centered. let me show you what it looks like if it's not exactly centered. You can kind of tell. It's not super obvious. Let's do a draw a line, color equals color dot, let's go light gray, and then start equals offset size dot, actually I can just say center dot x comma 0f, and then end is, well, still center dot x, and then size dot height, and then we'll do another one across. So start will be from 0f to center.y, and then this will be size.width to, is that what I wanted? Yes, center.y. That should be good. Okay, this will actually help us visualize a little better that it's off center. That's too light. Can't even see it. We'll go with gray. That's a little better. So you can see it's off-centered there. I just drew those two lines centered. So now if I change this to actually draw at the offset that I calculated by subtracting that half shape offset. Oops, I didn't want to run in debug mode. But now you can see it's actually centered really well on top of him. Okay, so that makes a difference. I'm just going to comment those out. I don't think I'm going to need those again. Okay, so that drew our triangle there. So now let's do the same kind of thing for our circle and our square. So we're going to need to have colors for our circle and our square. And let's see, what colors did I want to use here? So I was using, for circle is blue, and square was green. So there's a couple nice little parameters there. And then what I want to do is, when I'm defining a rectangle, I'm going to need to pass in a size. So I'm going to calculate that once so I don't have to keep recalculating it. But again, it's a quick calculation, so I don't need to put it in a remember. So I'm going to say val shape size equals size, passing in shape size px and shape size px. And then let's define, let's go ahead and copy him, draw a square, and we do the same kind of translation. I'm going to do a draw rect instead, and he's going to need a top left. Is going to be offset dot 0, because remember, we're doing the translate to move 0, 0 to us, so we can just pretend we're drawing at 0. Not going to have a path, but we're going to have a size, which is going to be shape size, and color is square color. And then I can do the same thing for the outline. So top left and size stay the same. Color is going to be shape outline color. Style is shape outline stroke. And then we can do the same kind of thing for a circle. And we're going to say draw circle. And okay, so draw circle needs to have a center. And what center is going to need to do is he's going to need to have a, we're going to offset him by half the shape. So instead of drawing him up at 0, 0, so the center of the circle will be 0, 0, we're going to move him to the right and move him down by half of the size. So to do that, let's come up here again, and let's add in a val half shape size px equals shape size px over 2. And then I can say half shape size. No, actually half shape offset, because I want to have an offset that I can subtract. So half shape offset is an offset. Again, not an object, so we don't need to remember on him. And that'll be half shape size px, comma, half shape size px. And, oh, did I already do him? I guess I already did him, didn't I? Where is he? There he is. I'll just define him there instead. Okay, so he's good. And so now draw a circle. The center is going to be half shape offset. So we're just going to move over as though, well, from 0, 0, we're just going to move over to there. And so the radius is going to be half shape size px. Color is circle color. And now we can do the same kind of thing. Oh, I hit the wrong button. So center and radius are the same. This is going to be shape outline color. And this is going to be shape outline stroke. Let me get rid of this guy down here. Okay, so those are each of our draw functions. And let's go ahead and draw a couple of these guys. So let's go to inside our canvas. Right now we're drawing our triangle. Let's do a draw square. Let's say 100, 100. And let's draw the triangle at 50, 50. Well, let's say 100, 100, and then we'll make these 200, and these should be, oh, these need to be offset. And they're Fs. And this is going to be an offset, like that. And let's do a draw circle. Make sure these are all working. So we'll run that and see how they look. Okay, those are not looking very good. So we had our shape outline color. This is the stroke on the outside, so that's circle color. We've got our size, so the positioning is right. What's with the colors? Don't need him anymore. So why is the color not working? That's Compose Graphics color, so that one's good. So we got red, blue, green. I mean, it almost feels like I'm accidentally using shape outline color for the fill. So I've got it on the stroke. Stroke is shape outline width. What's the shape outline width? Maybe that's too thick. Oh, there we go. The shape outline width, I left at 48. There's the problem. What did I use for that? Shape outline width. What was I using before? 4dp. Yeah, so what ended up happening is because this was so thick when I copied it, it's drawing that outline and just overriding everything. So now if I change that to 4, this will work brilliantly. There we go. That's much better. And why is this so tiny now? There it is. That's much better. So that's how that should look. Let me change the positions just slightly here. Let's go with 150, 150, and then 200. And I just want you to see the overlap. Okay, so because of the order we're drawing those, the ones we draw later show up on top of the ones that we draw earlier. Okay, good. I'm glad I noticed that outline color. That was driving me mad. Why are these things showing up like that? They shouldn't be. Okay, so the next thing I want to do is define a toolbar up at the top so that we can actually pick which color, which shape we want to drop. And let's see. So to do this, I'm going to define a little toolbar button. And the toolbar button is going to draw something on the screen. So let's come up here and say new file, toolbar, or tool button, I'll call it, tool button. And he is going to be a composable. And we'll say fun tool button. And then I'm going to give him a draw function. So I'm going to pass in a draw function to say what to draw on that tool button. And that's going to be taking a draw scope and an offset. Come on, I just want to... Why is he not... Okay, well, let's see what... Oh, you know what it is? I probably have to put the body in there for it to... There we go, import class offset. Okay, and it's going to do something. And then we'll have an onClick, which is going to do something. And then we'll have a modifier. And I did it again. There. I really don't like how it keeps reordering those. It's trying to be helpful. It's not. Okay, there we go. So this is a little tool button that we can pass in a function to say what to draw. So it's going to be like the draw circle or the draw triangle or the draw square, and a what to do when it's clicked, and then a modifier. So this I'm going to draw. So I'm going to create a canvas. And I'm going to say modifier equals modifier dot size. And I need to actually have the shape size dp passing in, and he's going to be a dp. And then he's going to say size is shape size dp, and he's going to be clickable with onClick as the handler. And what is he unhappy about there? There we go. So that's just going to use this guy to be the click handler. And what is he unhappy about canvas up here? Import function canvas. Oh, it just wasn't imported. There we go. And so what I'm going to do to start with here is just say draw, passing in offset dot 0. So that's my button to start with. Let's go ahead and put this on the toolbar so we can actually see these toolbar buttons being used. So to do that, I'm going to need to have a scaffold around all of this. And he's going to have a top app bar, or just top bar. Yeah, top bar, which is a top app bar. And we'll give it a title of blah, 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 text. And inside there, just say graph. Grog, I should call this grog. That would be so much better. Extract string resource. There we go. Let's collapse him. And I need some actions on there. And he's experimental, so I gotta pull him in. There we go. So this guy is going to have a tool button where we're going to say draw equals. Is it going to let me use the function reference here? I don't think so. Let's say draw square. I don't think that's going to work there. Well, let's see what else we need inside here. So we also had the shape size dp equals shape size dp. I need the on click and I need the modifier. Oh, I want to default that modifier. Let's come up here. Yeah, I actually don't have to specify him. And we'll put him there. So it does not like having a function reference for that. So I'm going to need to just call him. Oh, because I haven't defined those yet. That's why. So in order for this to work, I'm actually going to have to define my scaffold a little deeper. So we'll come down here after I've defined those functions. That would actually help. And then I can just put the scaffold here, put the canvas and all his fun inside of it. And so the modifier from the outside that's coming in should affect the scaffold. So I need to put him in there. Modifier equals the modifier coming in. And then here I'm going to create a brand new modifier just to do this padding. So inner padding, there he goes. Okay, that's better. So let's see now if this is going to, so that's okay. Can I use the colon? See, I'm not sure if I can do it for a nested function. Receiver type. Oh, it's because it's got a receiver on it. So I'm going to have to do that. Now again, instead of using it here, I could just say offset arrow, and then inside here say offset. But because there's only a single parameter, I can just elide that and just call it. So that's one button. So let's see, we have square. Let's do circle. And let's do triangle. Triangle. There we go. So that should give us 3 nice little buttons up at the top of the screen. Let's take a look. And something is unhappy. No value passed for parameter draw square. Oh, I must have accidentally said define something. That was kind of silly. Oh, I hit debug again. Okay, and there we go. So now we can see we have on our toolbar these 3 buttons. Now, these 3 buttons are, do I have a, I do have a scaffold around. Notice how there's some extra space up in here. That's because I accidentally had a scaffold on the outside. I want the scaffold defined inside. And I think, let's go in here. We don't need the modifier passed in from the outside. But when I do my canvas, saying modifier.padding. I need to do that fill max size. We'll put them in here. Let's try that again. That should get rid of that extra space at the top. There, that's better. Now note that these guys are really cramped. So what I'd like to do is give them a little bit of spacing around them. In order to do that, let's go to the tool button. And I can just say inside here, I have a certain size, and then I can say padding 8.dp, let's say. That might be a little bit big, but let's see how that looks. Did that actually run? Okay. Oh, because I did it inside the shape. Let's do it on the outside of the shape. There we go. So we're putting padding around the shape. We define our padding, then we define our size. So it's going to be the shape size plus 8dp for the overall space he takes. And there we go. So we have graph and a nice little toolbar. So far, so good. Now, in order to make these toolbars do something, I need some data behind it. So I'm going to define some tool type. I'm going to define a sealed interface to describe which type of tool is currently active. And then we can keep track of that inside of a view model. So let's come up here. We'll say, give me a new file. And I'll call it tool type. And we'll say sealed interface tool type. So we're going to have all different types of tools. We're going to have a circle, a square, and a triangle. And then next week, we're going to add a line drawing tool and a select tool. So if you select something, you can move it around. I'm going to differentiate between the shape creation tools and the line and select by adding another sealed interface in here that I'm going to call shape type, which is going to be a subtype of tool type. And now I can define my actual types. So each of these, I only ever need one instance to tell me which toolbar is selected. So I'm going to use data objects there. And it's going to be square, which is going to be a shape type. And then circle and triangle. And then I'm going to have line, which is just going to be a tool type, and select, which is going to be a tool type. So this way I can actually say if something is a shape type, I'm going to draw it. Otherwise, I'm going to do some other kind of action. Now, in order to keep track of what I have on my screen, I need some kind of object for that. So I'm going to say data class, because I'm going to create multiple instances, one for each shape I draw on the screen. And he's going to have a shape type and an offset. Keep track of where he is. Now let's define a view model to keep track of all this stuff. And we'll call it graph view model. And he's going to extend view model. And inside of him, we need to keep track of two things: which shapes currently exist and which tool is selected. So we're going to use that same pattern we've been using before, where there are two properties, one that's private and one that's a public version that is more limited, so non-mutable. Now we could also use, there's some support in Kotlin for public and private types on a given field. So for a given property, you can define what its public type is and what its private type is. I'm not going to get into that right now. It's pretty new stuff, and I can't remember if it's actually been finalized. But it would actually reduce this. You'd only actually need one definition, which is a little bit cleaner. But I'm going to keep with the pattern that we've been using here. So I'm going to say private val shapes is mutable state flow of a list of shapes. And he starts off with an empty list inside of him. And 1 second here. Oh, that's a little better. Okay, and then I'm going to define the public version of that. Shapes is going to be a non-mutable flow. So list of shape equals shapes as state flow. Now we're going to do the same kind of thing for the selected tool. And he's just going to be a tool type, which will default to square. And then we can have this guy be selected tool, tool type, and just like that. So now we've got these guys set up so that the user interface can listen to them and then adapt when they change. But we need a way to actually modify them. So we're going to add in a fun add shape, taking a shape. And all he's going to do is go to that private shapes and say value plus equals shape. So that will create a new list containing this shape plus all the previous stuff that was in there. This shape will be at the end of the list, and this is going to be important when we're doing our, again, painter's algorithm, which order we display these things, which we paint them on the screen. And we'll say select tool, which is going to be tool, and I'm going to say selected tool dot value equals tool. There we go. So that lets us modify things there. Now in our main activity, we're going to need to add in our view model like we did before. So I'm going to come in here and we will say private val view model by view models and graph view model like that. So we got him set up there. And I want to pass that into my graph, or at least pass the things that I care about into my graph. So let's do a val shapes by view model shapes collect as state with life cycle, and it's going to be an empty list to start with. And let's import him. And then this is going to be selected tool. And default will be square. That should be good. And then we're going to pass these in there. So I'm going to say shapes equals shapes. Selected tool equals selected tool. Now these obviously don't exist so far, but I can just Alt-Enter and say create parameter shapes. Alt-Enter, create parameter selected tool. And now when I go, I will see it's added these guys on. But notice that they don't have default values. So I'm actually just going to move them up to the top here, that those guys have to be passed in. Okay. So now the thing we would need to do is kind of go backwards. We need to say what happens when somebody clicks on one of these buttons. Well, we're going to need a way to select that tool. So I'm going to pass in a on tool change, passing in tool type, and we'll do something when he's clicked. And then let's go back to our button again. And let's set in a tool here. So we'll say tool type, and then selected tool. So whatever's currently selected, and what color I want to use to represent that toolbar being selected. And let's see, was there anything else I wanted to put in this guy? So we got our draw, on click, our shape size, our modifier. I think that's everything we need there. So what we're going to do is determine what background color we want this button to have. So val background color equals if selected tool is equal to tool. So the tool that I'm representing, if it's equal to that, then I'm going to use selection color. Otherwise, I'm going to use color dot transparent, which just is basically going to have no background on him. So another one of the nice things with Kotlin, the if is an expression, so you can actually use it to pull out a value like this, as opposed to having to define a variable and then do an if, set the variable, else set the variable to a different value. Okay, so now let's come down here and let's say dot background color, like that. And let's see, what else did I want to do? I need to tweak some stuff in the usage. So let me go back to the graph. We've got our shapes and selected tool and on tool change there. When we're defining our toolbar buttons, we need to fix those guys up there. So I'm going to say tool equals square, selected tool equals selected tool, and this is going to be tool equals circle, and then tool equals triangle. And what is the one that I'm missing here? On click, shape size, DP. Oh, selection color. Which I have not defined yet. So let's pass him in as one of our 3 million parameters. And let's try maybe an orange. I did yellow before, but it doesn't show up too much. Is there? No, we don't have any orange defined here. Let's say yellow. Can I darken it? No, it doesn't work the same way. Let's go with yellow and see how it goes for now. We can always change it to something else later. So we got him. And then we'll do the same things down here. Those are all good. And now for on click, we're just going to define that as on tool change. And what is he not happy about? Tool type, but function unit was, let's take a look and see what he got here. So this guy is on click taking nothing. Oh, we didn't pass the tool type in. So let's actually pass that in there. And so this is going to be on click, taking the tool. And then we come back to the graph. That's better. Now we can do this guy, boom. And then this guy, boom. Okay, so let's see. Hopefully what this will do is this should show the square highlighted to start with. And then as I click on other ones, it should highlight those. No value passed for on tool change. Oh, okay, so we got to do that to go back to the view model. So on tool change here is going to be, I think just view model. We can use the reference on him. View model, select tool. There we go. Now let's try that. So the selections are not, oh, you can kind of see the yellow. But it's really, the reason you can't see it on the square is because of how I set up where the thing is drawn. If we go back to our tool button, notice that I'm drawing the background inside the size, where it says set the size to shape size DP. What's happening here is when it's drawing inside, it's completely filling the shape size. So the background color just isn't left visible. So if I move the background color first, it's going to be on the outside of the padding. So we should have 8 dp to make that background color visible. Let's try that, see if that makes it a little bit more visible. Yeah, you can barely see the yellow on here. Let me pick a different color. Maybe I could pick a gray. I don't really like gray. Or let me bring up a browser, and I'll say color wheel. And let's just pick a decent color. I kind of want an orange. Let's see what the... Well, that's not very helpful now, is it? I want the numbers. Let's say color hex. Okay, well, maybe this will work. Let's go into here. Let's go with that. And what do we have? So here's the RGB. We'll just copy those. Let's go over to our graph stuff and back to our graph definition. Make his default be... Can I just pass in the RGB, or is it color.rgb? I haven't done a custom color in a while. I can do HSL and HSV. Where's RGB? Really? From color long. Seriously, there's no RGB? Okay, I have to look this up. Hold on one second. Jetpack compose RGB color. Oh, so I apparently can just use the constructor. Okay. There we go, red, green, blue. Let's see how that looks. Might be a little bit there. That's much easier to see. I don't like that color, but we'll stick with it. It's actually doing our selection. So we can actually see it when I'm talking about this. Okay, so far so good. So now we actually have to start doing some stuff here. What I want to do is listen to the canvas for clicks and then drop shapes based on where the user clicked on the canvas. So we're going to go into our canvas, and inside there we're going to add a modifier to sorry, there's a dog barking in the hall. We're going to add a pointer input. And I could add a clickable here, but pointer input gives us the actual location of that click, whereas a clickable wouldn't. And on top of that, we're going to need to eventually distinguish between different types of clicks and drags and things like that. So I'm going to say pointer input, and he is going to add a detect tap gestures, which is going to have a finger location, and then we'll do something. And what is he unhappy about there? So that one's deprecated. Oh, we need to pass something in, but well, I'll show you what we need to pass in a second there. So what we're going to do inside here is based on what type of thing, what type of tool was selected, we're going to do something. So I'm going to say when selected tool, I'm going to say is shape type. Now is an operator that checks if something is of a certain type. So this is actually saying if selected tool is a shape type, then I'm going to do something about it. Otherwise, I'm going to do some other stuff. So I'm just going to go up to the when and hit Alt-Enter, add remaining branches, and let those just sit as to-dos for now. We're not actually handling those. But if it's a shape type, I'm going to call on add shape, passing in a shape, the selected tool, and the finger location. Now I didn't define on-add shape yet. We'll create that as a parameter. Let's see if that came out okay. It should have. There's on-add shape. I'm going to move him up to there. And then the caller is going to have to deal with it. And now let's think about what's going on with this pointer input. Must provide one or more key parameters to define the identity of it. What ends up happening with this detect tap gestures is he is defining a lambda that's going to live over a long period of time. And that one will still be attached as a listener on this item and not get recreated. We need to figure out under what conditions we need to recreate this guy. The thing is, he's going to be living across invocations of this. So let's take a look at what we depend on. We depend on selected tool, and I think that's it right now. Yeah, the only thing we care about right now, oh, and the on-add shape function. So these two guys we care about. Now there's two ways we can handle this. We could recreate this gesture handler every time those change, or we could make references to those. And Compose has a special function called remember updated state, or remember updatable state, I think it's called. And what this allows you to do is instead of directly referencing on-add shape, which will get captured when detect tap gestures is actually called, which doesn't happen immediately. So defining the pointer input says, after I've set things up, call this to actually set up how I'm going to handle the pointer inputs, and that ends up returning a lambda. Because of that, things like on-add shape and selected tool are getting captured once. If I left this as it is, you would see every button I click is always going to treat as the same selection. So let me leave it as that is for a minute, just so you can see that. I'm going to pass in a true here so that it never recreates the tap gesture handler. And we're adding a shape. We need to actually draw the shape for this to do something. And the caller needs to define on-add shape. Is viewModel add shape. So those should all be hooked up okay. I think if I run it, it should compile fine. Yeah, good. Okay, so now we just need to draw things, and we should actually have it clicking and dropping things on the screen. So let's go back to the graph and go all the way down the bottom where we were drawing these guys. I'm going to get rid of these. I don't need them anymore. And I'm going to say shapes for each shape. And then I can say when shape.shapeType. And I'm going to Alt-Enter on him and say add remaining branches. With circle, I'm going to draw a circle at shape.offset. And then square, I'm going to draw square at shape.offset. And triangle, I'm going to draw triangle at shape.offset. So now we should start with an empty screen and be able to drop things on it. Let me go ahead and run it. And we'll drop some squares. I'm going to switch to circle, but watch what happens. It still has captured the selected tool as square. So what we need to do is set it up so that it'll understand that it has to actually either recreate that pointer input each time, which is probably not what we want, especially because some of these tap gestures are going to be used for dragging, or we need to, instead of using on-add shape and on-selected tool directly, we need to indirectly reference them. So to indirectly reference them, we can come up here and say val selected tool, I'm just going to say ref by remember updated state, and this is going to be, oh, actually, I'll just pass it in. So selected tool. I think that's how you use it. This, by the way, is the first time I'm ever using this function. But let's see if that fixes it. So I'm going to say selected tool ref and selected tool ref. SmartCast. Oh, SmartCast is impossible there. So the shape coming in here, yeah, so the shape coming in, normally I can do a SmartCast, which means because this is shape type, because this is shape type matched, Kotlin can say, oh, well, inside of here, therefore I know it's a shape type. That's called a SmartCast. Shape only takes things of type shape type. It doesn't take things of type tool type, which is like, what selected tool ref is. Because this is a delegated property up here, we can't use that the smart cast. So we're going to have to explicitly cast this and say as shape type, and then that should make that work. The as operator is the way you cast in Kotlin from one type to another. There is also a really nifty one as question mark. And what that does for you is that says if it's not possible to do the cast, then just return a null. But we're using as here because we don't want a null. Okay, so now let's see if the tool type can change. So we're dropping down our squares. Let's pick the circle, and now we get circles. Pick the triangle, we get triangles. Ta-da! And it's all because when this detect tap gestures runs, it creates a lambda which captures what information it has at that point, but it never gets run again. Now, if instead I had passed in selected tool and on add shape, if either of those changes, I'd redefine the tap gesture handler. This is better because I don't want to keep redefining that handler. Now I should also do the same thing for on add shape. In our case, it's never going to change, but because it is a parameter that could potentially change, we really should do the same thing. So I'm going to say on add shape ref, on add shape. And all this does is, remember updated state, is it creates a spot in the compose tree, puts the value selected tool in it, and then every time we come through, it just updates it. So the remember here is a little bit of a misnomer because it's always changing the value in that bucket. It's just that it kind of acts similar to remember in that it creates that hole or that little bucket in the compose tree. In this case, we're just using it as an indirect reference. So I should be able to say on add shape ref, and there we go. Let's run that again just to make sure it's still going okay. Squares, circles, and triangles. Looks good. Now there is one thing I really don't like about how this is actually working. Watch what happens when I drop one of these guys. I'm going to go here and just click. Notice where it's being dropped. It's being dropped relative to that upper left corner. And if I'm using my finger, it's going to feel like these things are not really where I clicked. Because intuitively, when I tap with a finger, it should feel like I'm really putting the shape on the screen right where my finger is, so kind of in the center of my finger. So what I'd like to do is, instead of directly using that finger, subtract that half offset from it so that it basically moves the upper left corner up a little bit more. And then it should feel like it's centered. So here, let's do this. And there. And so let's say, what are the parameters on this guy? Shape type. and then offset. I'm going to say finger minus half shape offset. And now that should actually fix it up so it actually feels really nice. So I'm going to drop it, and boom, it's right where my finger was. And it's little things like this can make a user interface feel a lot more comfortable. If you just pay attention to what might feel like a better way to do things.